The next part, 2%, is something called percent of change. In order to sort of wrap your head around this, this is on page 22 in your books. This is saying that you want to know what is the percent that something increased or the percent that something decreased. Meaning you're wanting to know how much did it increase or decrease, but I want it represented as a percent. So we don't want to know that it went down by 75. We want to know that it went down by 12%. A lot of times we can look at your grades and say, well, yeah, you decreased, or yeah, you went up. And you might say, well, I only went up 2 points. But what we can do is we can compare that and say, yes, you went up 2 points. However, you had a 5% increase. That's awesome. That's great. So percents of changes a lot of times can help us put things a bit more in perspective than just looking at a simple difference. In order to calculate the change, you subtract the larger number minus the smaller number. Whether it is increase or whether it is decrease, larger number minus smaller number. Then what we can do is, the other thing we have to know is the original number, or the original amount. And this is going to be the amount or the number that you start with in the problem. If it's a percent of increase problem, meaning I start from point A and it goes up, then the original amount is going to be the smaller number. For percent of decrease problems, the original amount is going to be larger because I started somewhere and it went down. There are 2 ways to go about it. Today, I'm going to show you both. You only need to learn one, okay? So out of these 2, you only do one. Up until this point, you've been able to have one that you prefer. Do you like the proportion or do you like the equation? So you pick the one you like the best. Now, I've given you 2 different proportions, and I've given you 2 different equations, in case you weren't sure if those being 2 different ones. So for the proportions, you look at the amount of change over the original amount and then percent over 100. So percent over 100 is not changing at all. Another way to think of it is on top, you're going to do large number minus small number, and on the bottom, it's going to be the number you start with. And it's going to equal percent over 100. If you want to do it in equation form, you do the amount of change, then divide by the original, then you multiply by 100. Or you can do the large number minus the small number, which is your amount of change. Notice it's in parentheses. In both of these cases, when we have large number minus small number, it's in parentheses. That is to indicate, hey, I need to subtract this first, because order of operations says do parentheses first. And then you're going to do divide it by the number you start with, and you're going to multiply by 100. Let's do a few examples. So looking at page 23, we're going to do percent of change. Now these are all percent increase problems. I'm going to show you how you can tell that it's a percent increase problem, even if it doesn't come right out and say that it's a percent increase problem. Notice that the directions say we have to round to the nearest percent. So the first one says, find the percent of change from 4 to 7.5. So the very first thing we've got to do is we're going to subtract 7.5 minus 4, and that's going to equal 3.5. Whether we do the proportion or the equation, the very first thing we have to do is that subtraction piece. Now, even though this one says find the percent change, we know it's a percent increase because we started at 4 and we went up to 7.5. Most students think that if it says increase, you have to add, and you don't. What we are wanting to know is how much did it change. So this is going to be the amount it changed. If we're doing the proportion, we take the amount of change, in this case 3.5, over the original amount. We know the original amount is going to be 4 because that's the number we started with. And it's going to equal percent over 100, which we can cross multiply like we've been doing. And we get that P equals 87.5, but we are asked to round to the nearest percent, meaning nearest whole number. So we end up with 88%. If you chose to use the equation for this one, you would take the amount of change, which is 3.5, divided by the original number, which is 4. We then multiply by 100. And all you have to do is type this into your calculator. But if you do not have a calculator that does order of operations, 3.5 divided by 4 is 0.875, which we would multiply by 100, and that gives us 87.5, which we then could round to 88%. Let's take a look at the second one. Find the percent increase from 8 to 9.6. So again, the very first thing we have to do is subtract 9.6 minus 8, and that's going to give us 1.6. If we were to do the proportion, we'd take the 1.6, put it over the original amount of 8, and it's going to equal our percent over 100. Cross multiply. And in this case, it works out nice and evenly, giving us 20%. If we chose to do the equation, we still have to do the subtraction. That's not any different. And we get 1.6. That's your amount of change. We're going to divide it by the original number of 8. And then we're going to multiply by 100. So if you have a calculator that does order of operations, you just have to type it in. If you do not, you start at the left and do the division first. 1.6 divided by 8 is 0.2 times 100 gives us 20%. The third one, find the percent increase from 100 to 114. We know this is going to be an increase problem because we started at a lower number and we went up to a higher number. First thing we have to do is the subtraction piece. On any percent of change, percent increase, percent decrease, anything, we've got to do the subtraction part first. So we do 114 minus 100, and that gives us 14. That's our amount of change. In the proportion, that's going to go over the original amount, which in this case is 100. And we're asking for the percent out of 100. We can go about and do our cross multiplying like we normally would. And then we do our division. And we end up with 14%. If we wanted to do the equation, which again, you're not having to do both, you only have to do one, so I'm just showing you both ways, so whichever way you're more comfortable with and whichever way you have a preference for, you can go with that method. We take our amount of change, which we got by subtracting, and we ended up with 14, divided by the original number, in this case that's 100, and then we multiply by 100, and that times 100 is going to be the same way every time. So we have 14 divided by 100, because we know if we had a calculator that does order of operations, we can just type that in, but if we don't, we divide 14 by 100, which is 0.14. And then we multiply 0.14 times 100, and that gives us 14%. We get 14 as our answer, and the unit in this case is percent. Now for the last one. In a given year, Hillsborough had a total of 7.5 inches of rain by March 1st, and a total of 22.5 inches of rain by July 1st. Find the percent change from 7.5 to 22.5. We know it's going to be increased because we went 7.5 up to 22.5. So that's what tells us it's going to be an increase. Now, if they didn't tell you you're going 7.5 to 22.5, you have to put a bit of common sense and a bit of logic into this. There's March 1st and July 1st. March 1st comes first. March 1st comes before July 1st. That's how you know that's got to be your first number. So we do our subtraction. 22.5 minus 7.5, and that's going to give us 15. So our amount of change is 15. Our original amount where we started was in March, which is 7.5. And we know it's going to equal the percent over 100. This is a good opportunity for us to look at this problem compared to the other three. When we set them up in proportions on the other three, we got a normal fraction. In this case, we have an improper fraction with 15 over the 7.5. This should be a dead giveaway. Our percentage is going to be over 100% because we have an improper ratio with 15 over 7.5. Therefore, we know our number is going to have to be bigger than 100%. We cross multiply like we normally would. 7.5 times P and 15 times 100. And we get 7.5 P equaling 1,500 or 1,500. So we divide 1,500 divided by 7.5, and we end up with 200, don't forget your units, percent. For the equation, if that's the method you prefer, your amount of change is 15 divided by your original number, which was 7.5, because you had 7.5 inches of rain in March before you had 22.5 inches of rain in July. And then we multiply by 100. Our calculator that does order of operations, we can just plug that in. But if we don't have one, we would say 15 divided by 7.5 is 2. And 2 times 100 is going to give you 200%. Moving on to page 24, the final page for this assignment. We are now going to do percent decrease. We know these are percent decrease problems because we're going to have one number and it's going to get smaller. So the original number is going to be bigger. That's how you know it's percent decrease, even if it didn't come out and say it. We are still rounding to the nearest percent. The steps we took in the previous problems, the ones with percent increase, are going to be the exact same steps for this one. For the first problem, we're asked to find the percent decrease from 1,250 to 1,120. We go about subtracting 1,250 minus 1,120, and that gives us a change of 130. For our proportion, we put 130 over our original number of 1,250, and we're looking for the percent out of 100. Cross multiply like we've been doing. Then divide. And we get that P is 10.4, which means that we're going to round to get 10%. Because the 4 is going to round down. If we chose to do this in an equation, if that's your preferred method, we still have to do the subtraction to get 130 divided by the original amount of 1,250, then we multiply by 100. 130 divided by 1,250, because we're going to pretend we don't have a calculator that does order of operations, is 0.104. We multiply by 100, which is what that number is supposed to be. And we get 10.4 which will round to 10% because we round down due to the 4. The second one, find the percent decrease from 9.6 to 4.8. Once again, same steps. First thing you got to do is subtract the 9.6 minus the 4.8, and in this case, we end up with 4.8. So our change is 4.8. Our original amount is 9.6. We know it's the original amount because that's where we're starting. We go from 9.6 to 4.8, and we're looking for our percent out of 100. We cross multiply like we normally have been. And we divide. And we end up with 50%. If we chose to do the equation, we still have to do the subtraction piece of 9.6 minus 4.8, and that equals 4.8, which is our change, divided by our original amount of 9.6 times 100. We know our calculators at school can go ahead and do order of operations, but if the calculators at home can't do order of operations, we have to do the division first, and that gives us 0.5, which we then multiply by 100, and that's how we get 50%. The third problem, find the percent decrease from 120 to 95. Subtraction first, we know it's decreased because we started 120 and it's going down to 95. 120 take away 95 is 25. We set up our proportions. 25 is our change, our original amount's 120. And that's going to equal the percent over 100. We cross multiply as we have been all along. 120 times P and 25 times 100. Then we divide. And when we divide, we are not getting a very nice number. We get approximately 20.8. which we know will round to 21%. If we chose to do the equation, we know we're going to subtract first, and that's how we get 25. We're going to divide by our original amount of 120. We then multiply by 100. 25 divided by 120 is not a very pretty number. It's about 0.208. You don't need to go any more past the 208 because of where because of the fact that we're rounding to the nearest whole number. We don't need anything else after that. We then multiply by 100, and we end up with 20.8, which we know is going to round up to 21% because of the 8. The final example of percent of change. The average cost of a gallon of gasoline increased to $2.99 per gallon from $2.85. Find the percent of change. The first thing we want to note is that this is going to be percent of increase. So we go about knowing that the very first thing we have to do is subtract our numbers. That part's the easy part because all the subtraction's always been the larger number minus the smaller number. We haven't had to think about that at all. $2.99 minus $2.85 is going to give you 14 cents, which is 0.14. Now, we have to think, if that is our change, how much the price changed, what was the original price? Where did we start? We started at $2.85. We know this because in order for it to increase, it has to go up. If we start at $2.99 to get to $2.85, that's not an increase. That's a decrease. So since this is an increase because it tells us it's an increase, we know we're going from 14.14 over 285, and it's going to equal P over 100. We go about our cross multiplying the way we have been. And then we divide. Again, we're rounding to the nearest percent per the directions at the top. We get P is about 4.9, which can be rounded to 5%. We don't need any numbers after the tenths place because that tenths place is going to help us round to the whole number. If we chose to do the equation, we know we're still going to have to subtract, and that's where the 0.14 comes from because we have to subtract first. We divide by the original amount, which is where we began. If we're increasing, we know it needs to be the smaller amount, which is 285. Then we're going to multiply by 100. When we divide 0.14 by 2.85, we get a not so very pretty decimal. We only need to worry about the first 3 digits because of where we're rounding to. And when we multiply 0.049 times 100, that gives us 4.9, which we know we can round up to 5%.